Good morning. All right. Okay. Today is Tuesday, the 7th of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day. And I stream here on Twitch Monday through Friday. I'm working on a project called Basecode, which is a new programming language that I am designing, and right now I'm in the process of writing the Bootstrap compiler in C++. Get something sufficiently advanced so that I can actually start rewriting the compiler in Basecode itself. Let's see, yesterday I kind of extended my test case source file, and then discovered that my register allocator was not really working the way that I wanted it to. So yesterday, on and off, I worked on fixing up the allocator and fixing other bugs that kind of fell out of that. And this file now compiles and executes properly, which is good. There is one bug which is good because one of the things I wanted to fix was the compiler catching this kind of an error. But now the register allocation works properly, and we get the program to run and all the data is right. I enhanced the data definition inside of the instruction block. So now you can give a data definition a vector of values. So one value is fine, but you can also give it a collection of values. And then because now the data definition can have more than one thing for things like strings and arrays and other aggregate data, now I can format them much easier, and that comes out looking much nicer. Let's see. Yeah, so if we look here, this is the, all right, so this is the bool true on init. So if I go up here, actually we're doing the init on that one. So here we go. Bool true init. We get the address of that. We load the value into I1. We push the value on the stack, we push the format string on the stack, and then we push the number of arguments we call print. Then we're going to do a logical not on it, which ends up becoming an XOR. So we move the address of that variable, we load the value, we XOR it, we put it in I1, and then we store that back in memory. So that's correct. And we can see up here that it starts off true. We do a logical not on it, and it's then false. So that's correct. I believe one of these. Yeah, so here's an example where we're loading the address of unsigned byte max. And we're getting the value of it. And then so if we come down here, so then we're multiplying that times 4. So I8 is 4, so we multiply unsigned byte max by 4, put it in I4, we move I5 with 2, we divide I4 by 2, we put 4 in I3, and then we shift left 1 by 4, put it in 2, store it. And then here's where I'm doing a binary knot. So I load that same variable address, get the value, perform the binary knot, store it. And then that's the larger number that we're printing up top, and that looks good. And then this is where we do the print. This one. So signed byte min is blowing up. Hey, Sika07, doing okay. How are you? So I'm not 100% sure what's going on with this one. All the others are okay. $120. Yeah, that's correct. So, yeah, I'm not sure what's wrong there. Was I missing a semicolon? I was, maybe. Huh. Okay, that's weird. Why didn't the compiler complain about that? Well, yeah, I was missing a semicolon, but it should have died. Okay, so that's the bug. Well, part of it. That's the bug there. Now this constant, this is just a disassembler thing. I need to change the disassembler so that it scales the constant value to whatever size this is. But this is actually correct because this is A2's complement. So all these bits are sign extended. So it's fine. It's just, yeah, it's kind of it's confusing, right? You wouldn't expect to see a number quite that large. But the same is true, for here, right? We're doing the sign byte max, and, well, actually, no, that's weird. In the sign byte max, it is scaling it. Why isn't it scaling it here? Well, let's look at that, because yes, I am just assigning a value to the register, but it gets sign extended because I have to turn it into a 2's complement number, right? So the way that the value is parsed by the parser, I get the sign, I get the positive integer, and then I have to turn it into a 2's complement. Everything is 64 bits internally. So all registers, all fields are 64 bits wide. So when I turn it into a 2's complement, even though I'm only accessing a byte, that's a zoned element of the full register. The full register is a 2's complement of that value. So the whole thing is sign extended in that situation, which is what I would expect. That's correct behavior. It's just that the disassembler is showing us more than we would want to see because the size of that zone on that operation is only a byte. And we're showing it zoned in the other case. I'm not sure why. So that's what I was going to look at here. byte. Hey, S-Will6. I replied to it. Did you ever, what system are you trying to build on? Because you had that gist that you linked to me, and I replied to that gist. Are you trying to build on FreeBSD out of curiosity? Yeah, so there's a bug in Boost that appears to be a known issue with FreeBSD. I haven't looked into a way to work around it yet. Unfortunately, all the things that I found were, hey, edit the Boost header files, and then it will fix the problem. I'm gonna see if I can come up with a more elegant way of fixing that. But that's the issue. Obviously, if you're a FreeBSD user, this is probably going to cause you to break out in hives, but in the short term, if you want to build it on Linux, it has to do with the interval library that I'm using. It comes down to the limits and types includes on BSD. There's something that's the library expects, and FreeBSD does not have what those headers are expecting, and so that one library, of course, is what's causing the problem. So it has to do, again, it's the interval, so it would be boost numeric interval.hpp. Is the one, if I remember correctly from the gist, is the one that's causing the problem. And you're not the only one that's run into it. Other people have run into it. Can you link that gist again? I don't think I kept the link. Boost numeric interval FreeBSD error. Yeah. Can we double check? Oops, wrong monitor. Yeah, please specify a rounding control mechanism. This was the one. Let's see. Come on. Yeah, so if you Google this, and I think I tried a couple different variations, but this is not specifically FreeBSD, but it's the class of problem that's causing the issue. And again, if you look at these tickets for other platforms they've solved it on, it's just something that's missing in the header files. And this is the exact header file that's bombing when you're trying to build it. My guess is I'm using a relatively new version of Boost. Like, I'm right at the edge. My guess is that it's possible, if it hasn't been ported, officially yet, that maybe some of that stuff hasn't happened. I don't know. But anyway, that should give you an idea of what to look for. It's that one, right? But what that's the error you're getting on your platform, whatever you have, right? So what I'm showing you is this is a configuration or a porting issue. I'm not sure why on your FreeBSD environment it's not compiling. I haven't tried it myself, and quite frankly, I probably won't in the near term. But if you want, that's the issue. So if you want to use those as a reference for what's missing in the header file, because that's the other thing too. Like, it may not be FreeBSD entirely. It may be the combination of FreeBSD, the CPU you have. I don't know. So you'd have to dig into that hardware rounding HPP file and figure out, like, on your platform, why is it throwing that error? I'm guessing it's because something's missing in the header that tells it how to resolve whatever it's trying to resolve there for your particular configuration. Yeah, that's the one. Interesting. So the format library is ignoring my size specification. The minimum. Interesting. Okay, so that explains that. Okay. Not super high priority. So I guess let's just verify. Yeah. Okay. So it's putting the right thing in the right place. All right. But semicolon. Why isn't that tripping an error? That's not good. Yeah, that's not good. What am I gonna do? That's so I put a similar test up the top of the file. So the node here is a statement which has a right-hand side. Oh, right, this is we can ignore that one. So this is the type declaration. So we can skip that one. All right, this is the binary operator. This is the assignment. Now this is actually the This is the initializer version of it. Oh, crap, I didn't mean to turn it. Hit the wrong key. Debugging is so much more complex when you hit the wrong key. Oh. All right. 1, 2. Try that again. Okay. Semicolon. The token that we got was, yeah, it's a line comment. That's not right. Yeah, we got that. Okay. Yeah, that's not right. Oh, I also changed source file. So every source file in Lexer, I've changed most of Lexer. See, we've got Unicode now. Although now I'm just realizing that the code I'm using to do the formatted line output is wrong. I forgot to do that. Oops. So, yeah, we gotta change this. Of course, let's see. Could be I messed up the start and stop. Let's just look at the lines first. See if I'm changing the Unicode. I messed up. Oh. Right. Okay. Forgot. Hey, Mr. Anderson. There's one 3-byte code point in the source file, but it's happening after everything else, so, it's coming last in the error section that's being reported, so I don't think it's, well, that's no good. Because index is already incremented, right? Because we already read next already increases index by the width. So this would be let's take a look. So index is 10 and line start is 0. So line start is now 10. To 13. That doesn't seem right. But that's because Yeah, I knew doing this was gonna break it. Yeah, see, all of we're off by 1 on the start for everything. I think that's because now the way I'm doing it is I'm using the internal iterator, which is handling decoding Unicode if needs to. And the way this loop used to work, it was a for loop. And so the index variable at that point was always the current, not the next. It's always off by 1. Story of my life. There we go. That looks much better. So there's all of our lines. Let's just look at these here real quick. Yep, so there's our Unicode character. We are getting a what though? So at some point, I'm guessing it's the way it's handling the end case. Because that also could be incorrect. So end of buffer is true. So end is now buffer size -1. Buffer is 3790. We're 3789. Line start is 3790. Okay, yeah. So this is. We don't want it for both. And we may not even really like end up buffer. Yeah, that got rid of that. Okay. Not even really sure we need to create a line in that case, but. All right, so that fixed that. Which is good. Okay. Yep. Good. Ah, it's still not catching it. What the hell? They caught that one. but it's not catching this. Okay, that's weird. What line is it? 83? Line 0. Well, that's not good. We better fix that. Excuse me. Because the argument list, I think, already has, the argument list should already have a proper location on it, but I think, yeah, the reference has it, I think. Identifier has it. Symbol location. Okay. So now, if I go back to parser, put the breakpoint back here. Now the procedure call should have proper location. Wow. Oh, I see. Yeah. Yeah. Okay, so now the procedure call, there we go. That's about right. Line 62. Yeah, 0 based. That's correct. From column 0 to column 62. Yep. Okay. And so now we're going to set the location of that entire thing on the procedure call element. So now if I go back here to our scope, put breakpoint, go. Was too late. But the node has the information on it now. There you go. There's our procedure call. Okay, so what are we looking for here? We're looking for line 82, 0 based. Okay. It found it. How the hell? '84, column 19. So it's finding this one. Yeah, that's not right. Okay. How is it finding that? Yeah, it's going all the way from line 82 to 84. That's not right. Yeah, let's go into here. it doing? Because let's do this. We're on line 82. So our token cache already has a semicolon in it. So it got it earlier. Because of that. Right, so yeah, the problem is this is being too greedy. The other one worked because it hit a comment which doesn't have an infix parser. but symbol reference does, or symbol. I think that's what's going on. Yeah, that's the problem. But I think yeah. Oh, I actually missed semicolons in a bunch of places. Because I cut and pasted. Yeah, see now it's finding them because it's not. I think I don't really need the infix parser. I'm trying to think of why I had it. I don't think it's really necessary. So I'm going to leave it commented out for now. Because this, I think every case where a symbol is found, it's in a prefix condition. So let's take that out. And let's take that out. And we'll leave the parser guts in here for a little while, but Hey, Gmon. Okay. Now, I think let's take that out and let's see if that causes a problem. Because that's going to run into an assignment. No, good. All right. And let's take that one out because that's going to run into a procedure call. Good. Good, 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 good. Awesome. All right, let's review this. So in my test program, I hadn't put semicolons in, and the parser was not catching it for a couple of different reasons. And those have been fixed now, meaning that I added the semicolons into the source, but also the parser catches the fact that they're not there. In source file, there were a couple of off by one issues because I had just refactored this code to support Unicode. And the way this thing used to work, the loop was slightly different. And so in this case, the end is based on the index -1 because we've already read past the end at this point. We've read a character beyond where the end would be. And then the start isn't +1, it's just index because index is already where in the old version we would have to move to the next index. And then I have some test code in here, which I'll leave for a little while, that will just dump out the lines to make sure that the line indexing and everything is working correctly. In parser, I commented out symbol infix parser. I think we can ultimately get rid of it. And I took the symbol infix parser out of the infix map. And then in the CPP file for procedure call infix parser, I have to set the location, the start and end location on the procedure call. I wasn't doing that, and I'm sure we'll run into a bunch of little nodes here and there where I'm not setting the location. I commented out the infix parser implementation. Again, I don't think we're going to need it anymore. I took off the subtraction here because I actually really don't want to do that. And then here, so in parse scope, we're looking for just thinking here. Yeah, this doesn't read right to me, but after we've parsed a statement, if it's actually a statement, and there's only two cases where it wouldn't be, line comment, block comment, then we need to look for a semicolon. This was just breaking, which would have then just ended the scope and the caller would have gotten something valid. Here we need to return null because there's nothing there and we want the whole thing to unwind. And then in program for procedure call, so when I'm taking the AST node and I'm converting it into a code DOM element, I have the AST node in scope here, which has the location information on it. So I create the procedure call and then I set the location information on the element that I created. This actually spans the entire procedure call, so this would be from the beginning of the identifier to the closing right parenthesis, but not the semicolon. So, I mean, I think for now that's okay. And then in make identifier reference, I'm taking the location from the symbol and setting it on the reference. Hi, DiaZZMS. I am working on a compiler for a new programming language. The programming language I'm designing is called Basecode. I'm building a bootstrap compiler in C++, so that's what you're seeing right now. Okay. So the next thing I would like to do is, let's take these out because these are just kind of sanity checks for the register allocation. Boolean is good. Where's my calculator? duplicates. Yeah, 1 and 1. Seven. No, it's 8. So this will be. That's right. No. Oh, totally wrong. Oh, right, because it would be. Yeah, because we're subtracting. Yeah. Okay, so this is kind of the pattern I want to follow. So really what I'm trying to do here is just verify that like all of our primitive numeric types, they work. And you know, the parser supports hex, it supports binary. So I want to kind of assert, right, that all of these, no, it uses 2's complement. Course, so these would be fine. How am I going to do that? There we go. Oh, Yeah, I'm doing this from memory. My memory sucks. So I undoubtedly have the wrong constants in here. Okay. Dollar is hex, percent is binary. That's old school. And yeah, and I even do octal too. Which, yeah. So let's see, 127, 177. So let's see what happens. Well, it didn't blow up. Of course, that doesn't mean much. Okay, so let's just look at Boolean stuff, whatever. That's fine. So U8 min uninitialized, we got a byte. So let's go down here. That's B0. Okay, so here's where we're loading U8 min, storing 0. We're loading U8 min 0. Am I loading it twice? Oh yeah, no, I am doing, yeah, it's gonna be the same value because it's just different parsing. So then max, these are all 0. Then max, yeah, 55, 255, 255. Yep, it's working. So then one of these was, okay, so here's the signed byte min, negative 128. There you go. There you go. That's the Oh, interesting. No, that's correct. Yeah, it's okay. Yeah, that's that. I made that note to myself about that. Yeah, good. Max, 7F, 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 7F. So all these are working correctly. That's, really what I was trying to test here, is that the parser is doing what it's supposed to do. Oh yeah, the Lexer, yeah, so the way this thing works, to your question, it's very simple. At the base, you have the source file, which is the, what I would call the tokenizer, right? To me, a tokenizer is just literally, here's a character, here's a character, here's a character, and it lets you move around, in the stream. The source file indexes the file. So it's just one big memory blob that you move through. But when it loads the source file, it goes through and finds all the line breaks, and it creates indexes so that you can very quickly say, oh, I'm at this position in the stream. What line am I on? What column am I on? And that makes, moving around in the file super easy. You just essentially query the source file for, position information because it's been pre-computed. And then the Lexer, which some folks call a scanner, same thing. The Lexer's job is just to give you tokens. So I said token earlier, but some of this stuff gets jumbled. So the source file gives you runes, essentially. It gives you characters, is what it does. And then the Lexer takes characters and turns those into tokens, which can be, like a token could be one character, it could be 20 or 100. Just depends on what it is. So this is one token, which from the Lexer is a number literal token. And if you look at, so for numbers, I have one token class that has everything. And for numbers, I store the radix and I store what was actually parsed out, right? So the radix would be 16 and the string for that token would be 7F. Then later on in the parser, we deal with doing conversions and things of that nature. So this is an identifier or symbol. This is a type declaration. This is a binary operator. So it finds the individual tokens as a stream. So the Lexer starts at the beginning of the file, and it just goes through all of its possible state machine options, and it says, oh, okay, the first thing that I see is a line comment. Here it is. And then it's going to keep seeing line comments. So every time you ask it, it's just going to keep giving those back until it says, oh, I see an attribute. And then it's going to say, I see a string literal. Then it's going to say, I see a semicolon. So then the parser deals with the stream of tokens. The parser is designed to trigger, there are two states in the parser because I'm using a Pratt parser model. So there's what's known as the prefix state, meaning that we're starting from scratch, meaning there's no previous expression that was being built upon. So we see that so it's actually the token we would get is, we get a attribute token, I believe is what I called it. So we would have a prefix parser, right, that can respond to that. We have a prefix parser that responds to a string literal and a semicolon, and we have a prefix parser that responds to a directive, and so on and so forth. Now, when you get into, typically with parsers, the complex stuff, is when you do things like, you know, U8 max U times 255 plus 6 minus 2, right? This is where things get complicated, typically. So this is where Pratt parsers are super awesome, because what happens is when you, like I said, there's two states, there's prefix and there's infix. And infix can become postfix if you need it to. So what happens is we prefix parse this, we prefix parse this, we prefix parse this, but the binary operator multiply is an infix. So inside of the parse expression implementation, you'd first do your prefix. If that succeeds, you loop and you basically say, okay, are there additional parsers that are infixed where the precedence matches the precedence level I'm at? And so here, the precedence level is going to change as we handle these additional binary operator tokens. So what's going to happen is this is going to become an expression. This is going to get ordered properly. Then the result of that, 6 gets added. Then the result of that, you know, 2 is subtracted, right? I mean, and you can parentheses your expressions if you want. It handles that too. But that's, generally speaking, how the parsing infrastructure works. And then the parser creates an AST, which is just a very generic, ooh, that's not good. See, there you go. Expected token, semicolon, but found number, literal, ooh. See? So, good thing I guess I did that, because, you know, now we can fix that. So the way that the lexer works, yeah, this is what's missing, or not right, I should say. Question is, where should I put it? I'm going to put it here. So this is an ordered map, ordered multi-map, sorry. And so if you know, most scanners, lexers, tokenizers, whatever term you want to use for it, they are state machines. Some of them are more data-driven than others. Mine's kind of quasi-data-driven. And quite honestly, like, I could probably come back and optimize this some more. But the way it works is I have this multi-map, and it is ordered. So typically, you know, you have to put the leading character, leading rune, actually, now with Unicode, in here. So a slash, as an example, could mean a block comment, it could mean a line comment, or it could just mean divide. So we start from the most specific to the least specific. And the lexer loop just tries to resolve this, right? Same thing with the dash, right? The minus. In this case, we actually want to. Actually, so the order was correct. What's wrong is the number parser. Because what should happen is, yes, it sees this and it tries it, but it discovers that this should discover that there are no digits after it, which means it's not a valid number. Then it would return false. And then the lexer loop would then say, okay, what's the other thing that handles, you know, that symbol? Oh, it's this. Okay, try that. So if we go to number literal, and then in each one of these handler functions, I call these little lexers, they're kind of little mini state machines that handle that particular token class. So we're falling in here. Yeah. So the token, this would not succeed, wouldn't catch this case because the stream would have the minus in it. Okay, so if we get a minus, but we don't get any digits, then that's not a valid parse case. And then the Lexer should go to the next scenario in the list ordered through the multimap, because we asked the multimap, hey, give me all the entries that have this start symbol. There you go. Then it works. So let's see. Yeah, so we load the address of the U8 max U. We load the address of temp, right? So this is where we're going to store it to. This is the variable reference. We get the value, we get the constant, we do the multiply, we get the other constant, we do the add. We get the other constant, we do the subtract, then we store it. So, okay, good. See, explaining it, and I find bugs. Does Basecode have negative, negative, and plus, plus? No. No. It will have, you'll be able to do U8 max U plus equal 1, right? But you won't be able to do plus, plus, or minus, minus. Okay, so because of, so Mr. Anderson says, let's say, for example, you have the expression 2 minus 1. How does the Lexer know it should be 2 minus and then 1 and not 2 negative 1? The reason is because of spacing, right? For a negative number, the negative must be a part of the number, right? You can't be on its own. It's just not valid. On its own, it's a negate or a minus. And see, the number parser won't parse in the decimal case. So negative only applies in decimal numbers, or floating point numbers. You can't have, so if you have a symbol, right, the parser is not going to recognize that. So let's take an example of this. Actually, you know what? Let's do a signed one. So let's take an example of this value, okay? If I do this, right, I can leave the negative next to this, and it will be interpreted as a minus or a negate because the number parser, this is not valid. So that has digits is going to be false, and so this is going to end up being interpreted as a negate. If I had something like 2 minus 1, well, this is going to be considered a number that's negative, and this is not a valid expression because there's no operator here. But if you had that, then now it's 2 minus 1, right? So it's just, small things like that that make the difference. And, you could probably Oh, in some cases, yeah, white space matters, absolutely. So, especially for things like negate, right? That there are some operators, this being one of them, where you typically, again, could you build a lexer that's like super complex that handles this? That, you know, somehow, again, the lexer wouldn't really know. The parser would have to disambiguate it. You would, the parser would get to -1. The parser might say, oh, okay, they probably meant 2 minus 1, but then you're trying to make decisions for the user. It's just easier to just say that's a syntax error. And I mean, I'm not even sure that the compiler will error properly. We'll see. I think it would, but we'll see. Yeah. Yeah, it's just, it's not what it's expecting. But if I did that, it would be fine. Now, one of the challenges with most parsers, especially things that are like Pratt/recursive descent, see, then that time it works. And if I did 2 minus minus 1, that's 2 minus -1. So that should be interpreted properly. But you couldn't put the two, dashes together. That's not going to work. So anyway, why not have plus plus and minus minus? Because they're a pain in the ass. Because they're not needed. Because you can do plus equal 1 or minus equal 1. And there's just really not a whole lot of value. And the issue with the pre and post increment and decrement is that then you have to have pre and post, right? Because if I just did post or I just did pre, then everybody would want both, because there's all this mystery and magic in C land because, pre is supposed to be better than post. It just, like, stuff like that, those are things I'm trying to weed out, right? I want to have the power of C and C++, but at the same time, I want to weed out the stuff that's problematic. And to me, those, yeah, they save you a couple characters when you're typing. It's not, there's just not much value to them. And they just create ambiguity. And then talking about, like parsing and stuff, then that just makes things more complex at the language level because you have to handle all these pre and post fix operators. And the code that it generates, right? I mean, theoretically, you would think that a plus plus or a minus minus would, generate like an inc or a dec or something if the CPU supports it. But if you look at most compilers, they generate sub and add anyway. But for example, array plus equal 1 would return array size plus 1. Oh, well, you just wouldn't do post increment or decrement. Rust is the same way, right? Like you can't, if I had an array numbers, right? And I had an indexer that was U32, and if I wanted to index into numbers, right, I can't do that, right? That's not going to be supported. If you want to do that, you do this, right? It's cleaner, it's less error prone, and functionally it does exactly the same thing. It's just, you can't use the shortcut that you might be, accustomed to in C or C++. Okay. Guessing it's 178. Nope. 200, of course. Good old octal. Hey, Ralph Rita. Oh, 377. Yep, add is octal. Okay. I'm going to talk. I can't talk. I'm going to take a really short break. When I come back, we will continue and we will replace these other sections with the same pattern here for all the other numeric types. And then, yeah, that's good. Then the next thing would be just to verify binary expressions for everything, but also ranges, right? So I need to purposefully put the wrong values on, you know, an unsigned byte, an assigned byte, and so on and so forth. Make sure the compiler is catching those. Because dollar is, if you go back in time, dollar is historically the prefix for hexadecimal. Pascal uses dollar for hexadecimal, percent for binary. You know, C and C++ have used the 0x, 0b prefixes. Intel has always used H as a suffix, but I never really cared for the suffix form because one of the issues you run into with suffix is that's not valid, right? Then your numbers have to be 0 prefixed in order for them to work, which I just never really cared for. So I use dollar. Okay, I'm gonna take a real short break. I'll be right back. Okay, I'm back. Seven, 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 seven. And the underscores are optional. I just put them there because I find it easier to read the numbers with groupings, but you don't need them. Yeah. So what is that? Digit 0. Yeah. No. Okay. 10,000. Actually, though, this is 65535. Which I had right. One seven. There we go. That looks better. Yeah, because the sign bit is on, sign bit's off. Up here or here? Because I've got uninitialized and initialized versions. Well, let's put it in the calculator. So octal 10, 1, 2, 3. Yep, missing digit. So 10, 1, 2, 3, 4. Yeah, there we go. Then 7, 7, 7, 7, 7. Yeah, that's correct. Yeah, I don't have octal memorized at all. I mean, I thought, I might as well put support for it in here, but it's not a numbering system I probably would use all that frequently. It's, yeah, kind of bizarre. Okay, U16 min, I1 through 4. U16 max, I1 through 4. S16 min, 1 through 4. S16 max, 1 through 4. Okay, here we go. U16 min. Ooh, that's not good. Oh, it's basing it on, yeah, it's basing it on the right-hand side. Yeah, that's not right. So that is binary operator. Assignment. Yeah, that's not right. there's just several of them. Much better. See if there's any other call sites. There probably are. The assignment is a special case that I have that infrastructure, register for, which is on element, and it'll dereference a variable if it is. If not, it just allocates a temp. But assignment is slightly different. That's not right. just going to hard code this one now. Okay, that's a byte, byte, 0 bytes. Okay, word. Hey, that's good. That fixed that. Yep, perfect. Yeah, this is just a formatting issue. Great. Super awesome. Okay. So let's take a look at that. Okay, so I renamed these variables, try to make them a little bit more terse. I'm actually working on a compiler right now for a programming language. So we have the uninitialized true and false, and then the initialized true and false. Then for unsigned bytes, uninitialized min and max. For signed bytes, uninitialized min and max. For all the different bases that the compiler supports right now, so decimal, hex, octal, binary. Then we've got the initialized versions of all these. So unsigned byte min and max, signed byte min and max. And then same thing for words, U16, unsigned, uninitialized, min and max. So the typical things that I recommend are to start with assembly language. It doesn't really matter what variety of assembly language you want, or you pick, really, in the end. The idea is that you want to learn to understand how the machine actually works, right? And the only way you really can do that is to start with assembly language on some CPU platform. The ones I listed here are older, with the exception of Mars. Mars is current. But the idea is to pick a CPU, an ISA that's simpler, something that you can kind of, if you Google it, you'll find it. It may have moved on the Missouri State website. Keep in mind too that there's pipes in there because formatting stuff with Nightbot sucks. So make sure you don't grab those accidentally. But yeah, pick one of those, and then, you know, work in the emulator and work through. You can either, like if you do the Missouri State one, there's course material that's available online from them, or you can just find other problems and work through those in the emulator. Same thing with the x86 emulator, which is the first one, or Easy 68K. Easy68K has a lot of demos, and that's also, so Easy68K is also supported by, maintained by a professor who teaches this stuff. So the idea, is to work through several examples, build things. In the past, I've recommended that once you've kind of familiarized yourself with the emulator and with the instruction set, that you then pick a project, something small, that you can start from beginning and go to the finish all on your own. So like with Easy68K, you could build a breakout clone, you could build a snake clone, you could, build probably like a pitfall clone if you wanted. The idea is to pick something really small, something that's you can scope and finish. You don't want to try to build something super complex, and go through the exercise of building it entirely in assembly language and understand how that works, right? Because once you understand it on any of those CPUs, no, the CPU instruction sets are not portable, but the concepts are, right? So once you learn what memory is and you learn, how CPUs interact with memory, what a program counter is, what a stack is, how flags or condition registers work, you have now a foundational understanding of what the actual CPU is capable of, what the machine can do. Once you've successfully completed, a project in one of those development environments, then I would say you could move on to something like C. So why learn assembly language before C? Well, because C hides things. My compiler hides things, right? This is what happens. Even if your language is, intentionally relatively low level, my language looks like this, and that turns into this, which is a form of, this is bytecode, but it's a form of assembly. And, understanding what this is going to give you a huge leg up. So then you can, spend some time and learn, C. And I always recommend to practice the same project, over again. So if you built, like, say, a snake game in the assembly environment, then I would suggest building the exact same game. Don't make it any more complicated in C, because you're going to learn a bunch of stuff just trying to get that done, right? You're going to learn how you have to deal with libraries and dependencies and how to get that stuff, to build and to link, and how you should structure your project. You're going to learn a ton of things just going through the exercise of reproducing that game. The reason it's easier in these emulator environments is because they're all-in-ones. You don't have to go out to a separate program to run the assembler. You don't have to worry about graphics libraries or sound libraries. These emulators have some of that built in. And so all you have to do is interface with a memory map or the trap interface that they give you, and you can get that behavior. When you move to C, you're going to discover that, C itself doesn't have any of those things, so you have to then start using libraries. I would move on to C from assembly language. I would not move to C++. The reason being, again, is that C++, there's more noise that you have to kind of understand how to quantify, right? It's not worth it to really worry about, should I put a method on this struct, or should I use a class, or should I use inheritance, or should I use a template? Those are all just nice to haves, right? Those are all just things that make you more productive as a programmer. But if you get into those things too early, they're going to confuse you, and they're going to add more complexity to something that isn't really that complex to start with. So I would move on to C, and I would become very comfortable with C. When I say very comfortable, I mean you can start a C project from scratch. You can build a makefile, or you can use CMake. You can get it to build. You can include third-party dependencies. You can link to them. You can set the include paths. These are all things that a C or C++ programmer has to be able to do essentially in their sleep. So it's better to, learn that stuff up front, building something that you're actually enjoying building, and, get real comfortable with the environment, with the tool set, with how these things work, and also, obviously writing the code for your game in C. And then once you've done that, I would suggest then moving on to a slightly more complex project, say maybe increase the complexity by, between 25 and 50%, depending on how ambitious you want to be. Don't double it, just increase it some percentage, below 50, and work on that next project, get comfortable with it. And then I would say you can move on to C++ and start trying to digest the extra stuff that C++ will give you, and how you might use it, how you might structure solutions using those features, and gaining the understanding that not every feature that C++ offers is something that you need to use. Just because you can put behavior on structs, on types, it may not be applicable. Just because there are fancy templated smart pointers doesn't mean that you completely eliminate raw pointers, right? It's C++ is a lot less about the language, because if you learn C first, then really fundamentally what C++ is not that different. But there's lots of design questions that you have to be able to answer, right? There's lots of design choices that you need to be able to make, and the only way to really do that is, to spend the time building things one way and realizing that you didn't like how that turned out. Mr. Anderson says, what I found fun while learning is reverse engineering and modifying games. Yep, you can do that too. What can you build with C++? I'm learning React and stuff now. You can build online apps and reach many people. What about C++? Do you think it would be possible to be a self-taught C++ programmer? Sure, I'm a self-taught C++ programmer. But I would not necessarily compare C++ to JavaScript or TypeScript or CoffeeScript or whatever in that space. And I would not necessarily think of using C++. I mean, again, I'm not saying never, never say never. But I would, if I had to build web applications, C++ is probably not a first choice on the list. Obviously, with things like, WebAssembly, more doors are opening up for C++ development in, the web space. However, WebAssembly has a ways to go before, they're still trying to get fundamental stuff working in WebAssembly. I mean, yes, there are compilers and it'll do patchy stuff to make stuff work, but I would kind of stay away from that stuff for probably another year and let it mature. I'm certainly targeting all the stuff I'm doing to where I'm essentially making the assumption that in about a year, WebAssembly's the warts are going to be addressed, and it will be much closer to prime time. But yeah, if you want to learn it, you can certainly learn it. But again, I would follow the progression that I lay out for beginners. do not start with C or C++. Start with assembly language. You need to understand. I know this is very contrary advice to what everybody else says, but if you really truly want to write low-level code, you want to get the advantage of low-level code, you need to understand what the machine does. You need to understand what a CPU does, not the magic, fluffy, foo-foo, woo-woo, I'm a Python programmer and stuff, magic is happening inside of that Python box. No, 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 no. You need to understand all about that magic, what that is, and that's going to take time. So you need to prepare yourself. I mean, there's a lot of ground to cover, and there's a lot of details, but it's certainly doable. And if you, again, if you start at the, very beginning, you start with a CPU, doesn't matter which one, you start with assembly language, then if you spend the time with it and you build something, you're going to learn a lot. And then if you move into C and then solve similar problems, then move into C++. Now, in my opinion, total time there depends on the individual. If you actually put the time in, 2 years, 3 years, maybe, depending on how aggressive you are with it and how quickly, your individual aptitude for learning these things and applying these things. And I put that out there as that's probably about the time you would feel comfortable. You still will have many years to go in terms of becoming really proficient with it, but you should get to a point where you roughly know how you would approach solving a problem after that period of time. I am programming a compiler for a programming language that I'm designing called Basecode. I didn't ask about web app. I actually wish to do smart people programming. Oh, well, okay, so you're asking if you should learn C or C++ because you want to get freelance gigs in that space. I'm going to be brutally honest here. The C and C++ assembly language space is very small compared to web stuff. Your chances of finding a job building a CRUD application in the web space is much higher than trying to do anything in the low-level embedded space. Typically, the freelance work that is available in that niche tends to go to people who have contacts within companies. They've done stuff before and they're trusted. That's not to say you can't break into it, but the market is just not as big as what I would call the workaday programming in 2018, which is web development. Also, and this really kind of started, I would say, maybe 15 years ago, maybe even sooner. A lot of companies that are in the embedded space, they have pushed almost all of that work offshore. That they look for the lowest possible price when it comes to that sort of work. So, in my case, like I used to do a lot of embedded stuff. I almost do none of it now. There are some projects, but it's just a much, much different marketplace than it was, 15 to 20 years ago. Games are certainly an option, but games are a very closed marketplace. You have to basically have been a published developer in order to be a game developer. That's the unfortunate reality of it. Now, of course, nowadays you do have a lot of options that people didn't have 20 years ago. You can build an entire game and publish it on Steam. You can build an entire game and publish it on, the App Store or the Google Play Store, and that counts. But you actually have to do it. You actually have to build the whole thing, and you have to ship it, and you have to be able to point to it in the store, right? And you have to think about that as far as games are concerned that is the invitation to try to get into the game industry. So it's not guaranteed. It just maybe gets you conversations with folks. So C++, C generally for embedded systems. What about drones? Would it be possible to even build a drone company yourself? Yeah, Mr. Anderson responded there, and I agree with him. The drone market is, unless you have, which I think is not the case based on this conversation, but let's say that, let's use an example of somebody who's, a programming god. Let's say that John Carmack, when he's at home, he's bored, he decides he wants to play with drones, and he builds an embedded operating system for drones, and it's like the closest thing to AI that we have for drones, right? Like whatever he builds, like it's so freaking awesome that the behavior of the drones and the functionality of what drones can do is far above anything else that's on the market. Could John Carmack start a drone company and make it successful? Yes. Could I? No. Could you? No. And again, it's not all about programming, right? A lot of it is who you are, who you're connected to, who you know, how much money you have. Yeah, and actually, so that's a very good point. I know a lot of folks ask me these questions because, it's never explicitly stated, or not always explicitly stated, but they're asking because they want to know if they should put the time in so they can put it on their resume, or if they're going to get a higher paying job, or if they're going to be like Mark Zuckerberg and they're going to build something in their dorm room and become a multi-billionaire. And the answer I would give in general on all of that, right? If that's your motivation for asking, which again, I understand, but what you have to understand as well is that, in general, if you take the entire realm of popular programming languages today, I'm going to make a leap and say that if you know, say, Python and PHP, learning C++ or Java is not going to change your income situation significantly. It's not going to get you more gigs if you're a freelancer. If anything, it's going to hurt you because the market has hyper specialized at this point. And employers and recruiters are, they have buzzword bingo, and that's what they play. So if they're looking for Python and you say, oh, I happen to know C++ and Java and Go, that all that just falls off a cliff. It doesn't mean anything at that point. If they're looking for C++, the fact that you know Python and PHP is meaningless. So just understand that, it's not about adding things to the repertoire and then that somehow makes you more valuable. It used to be that way, it isn't anymore. Nowadays, it's all about what you've specialized in, what your niche is. And if anything, you're probably better off doubling down in whatever niche you have. So if you're a good Python programmer, double down on Python, right? Spend all your time on Python, build OpenCV, face recognition, Big Brother shit, you know, build MXNet stuff, and, you know, like that's when I say double down, that's what I mean. You know, focus on that niche. What are people using that tool set for? And what are they most likely going to hire you for if you have skills in that tool set? And, you know, S. Will 6 says, you know, decide what company you want to work for and then, you know, tailor your skill set to them. You can do that too, all right? Which you probably would end up having to do if you're changing jobs a lot anyway. What about competitive programming stuff? Is obtaining high amount of knowledge about algorithms important? It's important insofar as certain companies are going to expect you to have them essentially memorized. I'll give an example. Someone that I know recently had a phone screen and they were asked to solve the, Qualcomm crystal ball problem. So if you're not familiar with that one, you're told that you're given 2 crystal balls and there's a 100-story building and you have to describe an algorithm to find the optimum number of drops before the balls break to, you know, find out what story you should drop them from. You know, I'll cut to the chase. The answer is 14, and you know, it's mostly a math problem. It really actually isn't much of a programming problem. But you know, here's the thing: unless you're a genius, chances are the only way you're going to have any idea how to solve that problem is to memorize it. And this goes for a lot of such problems because many of them have what I would call non-obvious or trick answers to them in the sense that once you realize what the answer is, you're like, oh, okay, yeah, that was staring me in the face kind of a thing. Not to say that they're easy, but once you see the solution, often it's obvious in hindsight. And I tell people the same thing all the time. If you're going to be interviewing with FANG companies, or not even necessarily just FANGs, you know, if you're going to be interviewing with larger companies in general, but startups and FANGs are kind of the big ones in this space. And that includes companies like Microsoft and Apple. They're going to ask you to whiteboard these problems, and these problems are very difficult to tackle if you have never, ever seen them or practiced them before. So certainly, if you're going to be interviewing or you want to be interviewing, you should get Cracking the Code interview. You should read it cover to cover. You should go on HackerRank or whatever online, you know, algorithm testing thingamabob that you prefer, and you should spend time. Now, here's the thing though, be careful, because yes, you can spend time like on HackerRank and there's others out there, but those are on a computer. Oftentimes where people get stymied is they're asked to do these things on a flippin' whiteboard. And I'll be honest, like I mean, I can solve quite a few of these problems if I can write code and get it to run. But solving them on a whiteboard in 45 minutes, that's difficult, right? And quite frankly, again, the only way you're going to be able to do that consistently is if you have them memorized. It goes without saying that if you're going to be interviewing at FANG companies or startups that are kind of hipster and they want to prove how elite they are, you had better have things like hash tables memorized. Be able to build a hash table from scratch, not instantiate a hash table in Java or C# or Python. No. That's not going to work. You need to be able to build it from scratch. You need to know what hashing is. You need to know how that works. You should understand linked lists, doubly linked lists. You should understand binary trees. You should understand how to take a binary tree and turn it into a doubly linked list, and vice versa. You should understand the difference between, breadth first and depth first. You should understand what recursion is, like really, truly understand it. You should be able to explain what the advantages and disadvantages of what recursion are, what the limitations of recursion are, and how you would solve problems without recursion. And hint, hint, there, it's iterative with your own stack that's allocated on the heap, independent of what the operating system is giving you for call stack, right? You need to be able to at least approximate the cost of algorithms. Meaning you need to be able to look at something and say, oh, that's ON. Oh, that's ON squared. Oh, that's O log 2n squared. You need to be able to approximately do that. Now, it doesn't have to be perfect, but you can't, when someone says in an interview, hey, here's this algorithm where you wrote this, okay, can you tell me what big O that is? You can't blank, right? You have to be able to give at least a close answer, right? I mean, they're not gonna ding you. Like if you get the log variance off slightly or whatever, probably. Of course, it depends on them. But, the difference between something that's quadratic and not, right, is you need to be able to point that out and be approximately correct. Gosh, did I miss anything? And that doesn't even include, like, I've seen these things online where people I've never been asked these questions by Google, but I know other people who say they have, who work there. I've seen phone screens with Google where they ask intricate details about networking and TCP/IP and sockets, and that's all just trivia, quite honestly. So, you're going to have to, if you kind of roughly know that you might be asked some of these questions, like I was amazed, like one of these things I saw in Hacker News, this guy was asked, like what's the SYNAC, byte exchange, this is like low level and niche stuff, right? And he actually answered the questions correctly. I mean, I thought to myself, shit, no way, I'd have to look it up. I don't have that stuff memorized. So, ultimately it comes down to you need to cram, right? And you need to memorize. And of course, the more you do this, the more, accustomed you will become to being asked these questions, which then at that point, like the fact that you're trying to game it, anyway, I won't even go there. And yes, S. Will 6 is correct. This is 1% or less of the kind of thing that you're going to be doing on a day in and day out basis, especially if you're building some web app de jour. And I guess, I also should throw out there, so I talked about a lot of the brain teaser algorithm stuff, but I think you also should probably, especially if you're trying to go get a job with a FANG or some startup web company that thinks they're going to be the next Amazon or some shit, everybody's going to want to ask you about, how do you scale wide? How do you scale horizontal? How do you, they're going to ask you about distributed computing. They're going to ask you about cache coherence. They're going to ask you about, sharding and all that nonsense. So I would say that you don't need to be an expert in any of that, but you should at least understand the jargon, know the buzzword bingo game, and at least be able to have some canned answers as it relates to those things, right? and it goes without saying that if you're trying to get anything that's related to web development, you should at least understand all the basics of HTTP. You should understand what the textual representation of a request and a response looks like, and you should understand some, I say some, of the basics of what firewalls typically will and will not support. You should be able to at least on some level talk reasonably about how like caching works with HTTP requests. Again, I don't think you have to be an expert with any of that stuff, but it's like, it's buzzword bingo. They're gonna say HTTP caching. They want you to say CDN da 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 da, right? You just kind of have to learn what the pattern matching and the responses should be. Yeah, or don't work for any of the FANG companies, right? If you go get a job, again, I'm in the United States, so I'll use the United States as an example, and this is in no way, meant to be disparaging to Iowa or, Oklahoma, but if you go and interview with some company in Iowa or Oklahoma that is not anywhere near the hipster hot list, chances are you're not going to be getting these kinds of questions. You'll get some of them, but you won't get, most likely you won't get the brain teasers. But if you interview with companies in New York, in Seattle, Portland, California, maybe Colorado, maybe Denver, really any kind of the posh hipster, we think we're going to take over the world with our silly whatever idea it is that they've got, you better prepare yourself for that sort of questioning. Yeah, Big O is, again, it's shorthand, right? It's so funny that something that is essentially a shorthand that programmers talking to each other can say, oh, I think that's, is that, quadratic time? Is that log, whatever time? Is that constant time? There's really only 2 or 3 of them that are that important. It's just a shorthand way of encapsulating some kind of, to me, it's both a capturing of, well, you built it this way, right? And, it's going to have this kind of cost to it. So if you have a loop in a loop kind of a thing, right, that's going to cost this much. If you have a loop, it's going to cost, it's linear. If you have, something like a hash or an index in the memory, okay, now you're approaching constant time, and they make a big deal out of it, right? Which is kind of silly, but there you go. Caspius Labs asked, hi, what do you guys think of PHP? Is there a future for this language? Oh yeah. So again, like, I don't know who, I think it was Move. Maybe it was Move, or I can't remember. But somebody on here said like elitism is going to kill programming, and that's stuck in my head. Oh, Move, you're here, Move. Were you the one that said that? I can't remember. Anyway, I think it's true, right? I don't know what happened or when it happened, but we definitely do seem to be having this striation in software development where, people, I don't know, are they look down, right, on certain technologies. And look, was PHP 5x great? No. Certainly anything before that wasn't super great. But PHP 7, there they've started to address a lot of their shortcomings linguistically. You know, PHP 7x has classes, it has, you know, access level protection, it has, you know, inheritance and polymorphism, it has mix-ins, it has, you know, all the stuff that any other language right now mostly would have. And PHP has this other really nice attribute to it, is it's very easy to set up. It's very lightweight. There isn't a container or complex runtime environment that requires a shit ton of configuration. So there's lots of problem domains where PHP is fine. It solves the problem. It does what you want it to do. And performance-wise, you know, PHP is continually getting better for just a raw interpreter. You know, it's really quite decent. And on top of that, if you really want performance out of it, you know, you have things like hip hop and other, you know, back-end solutions that will turn it into native code or run it in an optimized virtual machine. It is true, right, that the big issue with PHP is all the legacy code, right? So when I say, was PHP 5x any good or anything before it? No, probably not. And if you do have the misfortune of having to look at a legacy PHP code base where there's really, it's just all pages and it's all templating and it's nasty, yeah, it's that sucks. But that's not, today, that's not really the fault of the language. The language has better ways of doing those things now. That it's just old code. And that's going to be true of anything, right? You can come across old Java applications that are just absolutely shit to work with. So, same thing with .NET. There's tons of legacy ASP.NET out there, and ASP.NET is nothing like ASP.NET MVC. So, yeah. So I wouldn't, you know, write off PHP. I would definitely say if PHP is the only language you know, you might want to diversify a little bit, which might be viewed as, you know, me being inconsistent on my previous point that you have to be specialized. And I still think that's true, but you want to, you know, if you only know PHP, then you might want to spend time learning Python, you know, or some other language, just so that you have something in addition to PHP. Because again, there is a lot of elitism, so if all you know is PHP, people might potentially look down on you for no reason other than that's just what they're doing. Yes, and you can definitely, if people are looking, you know, for ways to get gigs and make money, I mean, legacy code is definitely an area where certainly all the cool hipster kids don't want to spend any time. So, yeah. Ooh. Let's see here. What was I doing? Oh my God, don't even get me started on JavaScript. Freaking JavaScript. What did I do here? So on element register T, so element has a function on it called register for, where you pass in another element and then it figures out based on the context, hey, is there an assembler variable for this? If there is, we populate this based on that variable. If there isn't, then we allocate registers manually because it's just a temp. I added in a function here called size, which takes the size of, if there is a variable, it takes the size of the type of that in bytes and turns that into an op sizes. And yeah, so if we have a variable, we get the size from that type. Otherwise, we just assume it's a quad word right now. At some point, I probably will need to revisit that, because that's probably, anytime I have a hard-coded value like that, I probably know it's not quite right. So then in a bunch of places where we were, and then in assembler, I guess I should look at that one first. I put the op sizes on target register, and then on assembler we had push target register for integer and float registers, and now we pass the size and the register on there. This probably needs, like, I have a couple of these structures that all represent registers at different points. Probably need to go through and consolidate that, and then this might be a bit cleaner, but it's not horrible. So then in push target in the implementation, we just pass size into the type. So we have it. Then in argument list and a bunch of other places where we're calling push target, we have to pass the size, right, for that. So the thing to think about here, this is the target register for the thing that we're working on, right? So if it's an assignment, we're talking about the left-hand side. If we're, in the case where we're pushing arguments on the call stack, then we want to push based on the size of the argument itself. Binary operator, we pass the size in. This is a special case because we don't go through register 4 in this scenario. We do it slightly differently because of the way assignment works. But for relational operators and for binary arithmetic operators, we just grab the size from whatever register we got back from that call. Let's see, an integer literal, I was inferring the size, which was not correct. So now we get the size from the target register, which is correct. In Lexer, for the number literal parser, I have a flag. So we get if there's a negative, right, in front of the number, we get that. And then we have a flag that gets set to true if we got some digits after the negative. If we didn't get any digits, then that's not a correct number, and we return false. That allows the Lexer to fall through in the state machine and grab the -/negate token correctly. Return element, I just temporarily pass in a 64-bit size here. This all has to be revisited when we get to that point, so I'm not gonna sweat on that one too much. We talked about unary, I think. So that was that. Watching JS trends is kind of funny. In about a year, the same people went from jQuery is the best thing ever to jQuery fucking sucks, it was never good. Yeah, I don't know, man. Why don't I use something like Vim? Oh, you mean like this? Oops. Yeah, I use Vim. But here's the thing, right? I had this conversation with somebody the other day. They asked me, they said to me, I don't get it. I use Sublime Text. I'm pretty good with it. Why do I need to learn Emacs? In this particular case, it was Emacs. I don't understand what the benefit is, right? So, I told him, here's my take on it, right? my take on Vim and Emacs, and I use Vim, right? So I am implicated in this just like anybody else. Vim and Emacs are difficult to learn. And because of that, going back to this elitism thing, I have grown to suspect that the reason people say, oh, you should use Emacs, oh, you should use Vim, oh, you should, is because in the back of their mind, they know that learning those editors is non-trivial. And therefore, when people do it and fail, or when people say, oh, I tried to learn Emacs or I tried to learn Vim and I just couldn't do it, then it gives them an opportunity to go, ha, 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 I'm an Emacs expert, I'm a Vim expert, and you are a lowly, programming pile of pus because you have to use this editor that's not running in a console and, it does all these fancy things for you and, blah, blah, blah. So S. Wills points out what I was just about to say. There are practical reasons why people end up learning Vim or Emacs, although Emacs is less common in this situation. VI and Vim are the de facto here. If at some point in your career you had to remote into via SSH or something of that sort to a Unix type host, what were the editors that were available to you that were not shit? Nano is not all that great. That was VI or that was Vim. So there are practical reasons why people learn these things. However, setting that aside, right, most of the folks on here who are asking about Vim or Emacs are not operations people, right? They're programmers or they're people who are learning to become a programmer, and they haven't even contemplated what operations work would look like. So I exclude that as it could be a compelling reason for some folks at some point in their career. And the truth is, if you're in that boat, you will learn VI or Vim or Emacs or something of that nature because that's what you have to do, right? And at that point, there is now a true pragmatic reason in the meat space of reality why you must learn those tools. And that in and of itself will give you additional fuel, so to speak, additional reason to focus on learning it. Beyond just, oh, all the cool kids in IRC say that if I'm not using Vim or Emacs, I'm a loser and I can't program. So the reason I don't use Vim for day-to-day development, because contrary to what you might assume, setting up Vim or even Emacs to be a full IDE is non-trivial. And my experience with it is that it's unstable. Plugins disappear, they come back. It's not worth it, right? At the end of the day, I can use JetBrains IDEs. They all have the same key bindings. They all have the same features. Yes, I bitch about CLion a lot. They're not perfect, but if I compare my productivity in CLion to productivity at this level with what I would have to do in Vim, it's just, there is no comparison. I mean, I would be spending a lot of time every day just dicking with my Vim RC to get it to work stably. And I don't want to do that. So do I like Vim as a text editor? Yes. And when there really is no IDE for the things that I'm working on, that's the editor I use. But it's an editor, and that's essentially kind of where its power ends for me. And it's kind of fits in the same category for me as why aren't I using Linux as my desktop operating system. You know, I just don't want to spend the time on it. I want to use something that by and large just does what it's supposed to do. So that's why. But exactly what Mr. Anderson says. If you like Sublime, use Sublime. If you like 4Coder, use 4Coder. If you like, you know, BB Edit, use BB Edit. If you like Vim, use Vim. If you like Emacs, use Emacs. It doesn't really matter, you know. Whatever tool is the most productive for you personally is the tool you ought to be using. So, what's wrong with Notepad? I've known some people who are very productive with Notepad. I mean, again, it's really a lot of this stuff comes down to what you saw first, what you were introduced to first. And exactly. That's the problem, right? It's not true, right, that you have to use a particular editor or you aren't a programmer, right? What do you write a Word document or Markdown in? I asked John this and he said I use Vim for that. Again, for generic text editing / what, like S. Wills said, DevOps type stuff, which, you know, if I'm not specifically writing C or C++ or Rust or something that, you know, I can get better leverage out of the IDE, I'm using Vim. And I'll even read code. Like if I download some open source library or whatever, I will open it in Vim and I will read it in Vim. So, you know, I don't want to sound hypocritical. I mean, I use Vim because I learned VI ages ago, and then Vim was just a natural progression for me. So writing like a Markdown document or a text document in Vim is, you know, not complicated. I can do that, right? And Vim does just fine. And if you're like, if, you know, John Blow, he uses Emacs, that's what he likes. Yeah, that's probably what you're going to use. Now, do you have to? No. I mean, is there anything magical because John Blow uses Emacs to write a Markdown document, or that I use Vim? No. See, that's the thing we got to get away from. At some point, see, I'll make an observation. I don't know what this is, but I'll make it anyway. At some point, John Blow said, fuck everybody. I'm just going to write text documents in Emacs. He doesn't give a shit, right? He's just going to use the tool he knows how to use, and he doesn't care what you think. But he also would tell you, I think if you asked him, is there a magical reason, John, that you use Emacs? He would say, no, Emacs sucks. Because he's also said that, right? Which is true, right? A lot of those editors are not, they are what they are. And yes, there's power there, but they're far from perfect. And so, you know, I can tell you this for a fact. John used Emacs because he went to a university and that's what they showed him. I used VI years ago, right, in work, which then led me to using Vim. I use what I use because that's what I chose to use. There is absolutely zero magic in anything that I do. There's zero magic in anything that John Blow does, or anybody else on the internet, or any other programmer you choose to look at, right? Their tools are not defining their skill set, right? Their tools are not defining their skill set. They are who they are regardless of what tools they use. You could force them to use other tools and they'd gripe about it and they'd be pissed off about it. But fundamentally, their skill set has nothing to do with the tool. So just remember that, right? That anytime anybody asks tool questions, this is what I always come back to. It's like, I get the impression that either they're using a tool and they think if they switch to this other tool that the magic pixie dust will rain down on them and then like they will become awesome programmers. Or they haven't done anything yet, they haven't written any code, they're just looking at what all these other people do and they're like, okay, well, what should I do? Well, yeah, that's a tough question, that's a tough nut to crack. And I would say the answer there is you just try things until you find what you personally like, right? Not what somebody else does, what you personally like. And then you have to be able to nut up enough that when trolls on the internet tell you that whatever you're using isn't Emacs or Vim, you can say, fuck you, I don't care, right? When was the last time you got X done, right? No, I know, but I think maybe you don't think that, Dr. Robot, but I think other people do. So I use your question as a jumping off point for that little rant, right? So there is no magic. Just remember that, no magic. There was a book written, no silver bullet. It's still true. So Born to be Reborn says, any cool keyboard shortcuts used for C-line, like moving lines up and down? See, this is the other thing too. Like, are there shortcuts that do that? Probably. Do I know them right off the top of my head? No. You know how I move lines up and down? I'll show you. You ready? It's gonna blow your mind. Okay. I copy it, I delete it, I go up, and I paste it. Now I'm sure that like at least 3 people are now searching on, Google, trying to find the shortcut keys for C-line so they can tell me what an idiot I am, and that if I just did this key combination that the editor would actually just shift the line up. And it probably would. But I've said this stuff before. You have to understand that, yeah, I'm doing it wrong, right? See? I knew there'd be one. The thing is, it all comes down to what you have memorized, right? And, believe it or not, like, I'm just not one of those people that can go on a cheat sheet and look at the 500 key bindings for something and, by the afternoon have the whole fucking thing, memorized, right? I can't. The other issue is, and I mentioned this before, yes, there are key bindings in all sorts of tools that do really cool stuff. But if you were to order those key bindings by the prevalence of use, right, what I find is the ones that I don't use every single day, I forget. And then I have to go and I have to look them up. I have to stop. I have to hunt in documentation. Oh, yeah, that's right. It's Control-Shift-Up. Except on my Mac, I would have to rebind Control-Shift-Up because that's what activates spaces. So that's why I don't use that keyboard shortcut. Because I do use that shortcut for spaces. So I would have to either change the shortcut for spaces and then memorize that. You see where I'm going with it? There are reasons why, right? It doesn't matter. So to answer your question, are there great, cool keyboard shortcuts in C-Line? Yes. Go to their website. Read their lists. You'll find everything you need to find there about the tool, and then you can even customize it to work however you want. So Yeah, that's right. Sure. I mean, everybody customizes their environment, right? And you should. And eventually, after you do it long enough, you find all the things that you want to work a certain way, and you you adjust your environment so it does that every time. So before I head out for the day, a couple of announcements. On this Saturday, yes, the 11th. So it's going to be, I think it's 2 p.m. UTC time, which for me translates to like 8 in the morning or something. So I'm going to be streaming probably my regular time. I'll start my regular time on Saturday, and I'll most likely be online more or less all day because the Hackalong Horizons Hackathon is this weekend. If you want to participate, it's open to everybody, any country. You can have teams or not. The URL is up there. I also have the URL on my Twitch channel page, which is twitch.tv/nybbles.io. And yeah, if you want to participate, by all means, hit up that URL and check it out. And I won't be participating in the contest because I'm one of the admins slash sponsors, I guess. But hey, Dev Chatter. But yeah, I will be online, and I'll be doing I'll probably be working on Basecode or something. I'll figure something out. I probably will drop offline a couple hours here and there throughout the day. But in general, I'll be online more than I typically am this upcoming weekend. So yeah, so Hackathon, check that out if you want to join. And I am too lazy to read. When I earn my first money, I'll sub to you. I really appreciate your chat interaction. Thank you. Oh, you're welcome. I try to be helpful. Sometimes I go off on rants. I can't help myself. I will say this. I'm noticing more and more news articles about programmers who are homeless who are trying to find work. And that's kind of scary. I'm sure you guys have heard about David, the young gentleman who was, instead of asking for money, he was handing out, he had a sign, and he basically said, working hard, please take a resume, kind of a deal. And that got some notoriety because somebody who saw him in real life took his resume, read it, was impressed by it, and then posted about this on Twitter. The guy went to Texas A&M. He's young. I don't think he's been out of school that long. But, when I read that, I'm like, what the fuck? That's scary. And then on Hacker News, last week, there was a posting about a gentleman, I assume was a male, probably shouldn't assume that, in Portland, who was homeless due to medical issues and was trying to get back into the development space and was, of course, having a very difficult time with it. And I thought it was interesting reading the comments on that thread because there was definitely a serious cognitive dissonance, in my opinion. On the one hand, there were a bunch of people that were, hey, I just searched on all these sites and look at all these PHP jobs. Why can't you find anything? And then there were the ones that are like, what you have to realize is that, there's like 20 or 30 higher qualified people in front of you for these jobs, and you really have to stand out. And I kept thinking to myself, well, which one is it? Is it that there's all these jobs and why can't you find anything? Or is it, well, there's all these other people that are better qualified and aren't homeless, and you have to like do a dance, right? Or learn how to juggle or do magic tricks, right? So it's like, what the hell? But anyway, I'm seeing more of these stories, and I don't know how many of you lived through the .com crash, but this is starting to kind of feel like that a little bit. Very similar sets of stories, and anyway, just an interesting observation I've made over the past couple weeks. But yeah, I would say it depends on where you are and how old you are. Unfortunately, nobody wants to hear that, but if you are a 20-something and you are living in the Bay Area or Manhattan, then you could probably have all the jobs you want, right? If you are 30 or over and you are not able to afford living on the coast because you have a family, and it's just, unless you're making hundreds of thousands to millions of dollars per year, it is not economical to live in San Francisco, or Manhattan for that point. Though I guess technically rents have actually started to decline slightly in Manhattan. So instead of having to spend $6,000 a month for a 3-bedroom place, you have to spend $5,800 a month. But still, the reality is that that's an extremely limited amount of the programming population, and that doesn't. Of course, this one guy, he's in Portland, so you would assume that he'd have better luck. But also, what employers say they want, what they really want. Yeah, of course, right? Absolutely. And certainly, I would say that based on employer behavior, the primary thing that's driving them is not that they need talent per se, it's that they need talent at a certain price. So, and I think their designs on what that price ought to be, they're slowly pushing that down for a lot of people. And I think that's creating a lot of challenges. Could be. It could be. Although I know folks in Illinois and in Texas and Florida, and they're having problems too. So now, granted, I don't know anybody in North Carolina or in the South per se. I don't consider Texas part of the South, really. Texas is kind of weird. And I hear from folks that like Alabama right now is hopping, I guess. North Carolina always seems to be higher on people's lists. I've heard Tennessee can be decent. Right, it's the Southwest, yeah. But some people who don't live in the Southwest or the South will say that Texas is part of the South. And I always tell them, well, yeah, not really. See, there you go. You got two people from North Carolina. So I've heard that the job scene there is pretty good. So jobs in North Carolina, I think, yeah, I think that, you know, out of all the places you could go, I think that's, at least right now, seems like it's a good place to be. Mr. Anderson says, I was asked to do some C++ stuff for a friend's workplace a while back. Turns out I got there, it was Microsoft C script. Yeah, I would definitely say that if you're young, unattached, low responsibility threshold, and you can go anywhere, I would definitely say that one of the best things that you can do in trying to get a job is to go where the jobs are. You know, excluding the desire to go to San Francisco or, you know, New York. Obviously, if you can get like a security clearance, you know, Washington, D.C., Maryland, that area could be good. And some folks, they are able to do that. Of course, you know, you're going to be working for like Northrop Grumman or, you know, companies like that. But what are the winters like in North Carolina? We get a good snowstorm every 5 years. Is it like bone-chillingly cold? Pretty mild. Yeah, that's a positive. The problem with like the Midwest and as you head more east and north, the winters get really, really bad, at least from my perspective. I'm used to it being 60 degrees every day during the winter. 15. Oh my gosh. That's so cold. No. No, no, no. No, no, no. You'd have to put me in a bubble and roll me around. Do you like it colder, Dev Chatter? Ah, well, yeah, you wouldn't like it here then, because during the summer it's, I would say our threshold is 100 degrees every day. But I love the heat. It's because I'm a mutant. Ooh, you're getting close, man. You're getting close. All right, so I'm trying to find somebody here to raid. Uh, there's a streamer using random projects in Rust. So we could watch, you guys could watch Rust. Oh yeah, if you were streaming, I'd definitely raid you. I should really learn how to read Russian. You're quite welcome. I will be online again tomorrow at 5 a.m. I actually went over a little today. Yeah, let's read this. Use on. All right. I will, like I say, I'll be online tomorrow, 5 a.m. And this weekend, I'll be streaming extra because of the hackathon. So if you guys want to catch me then, I'll be online a lot. Probably get a lot of code done. So thanks everybody who dropped by. Appreciate it. And I'm going to raid this guy. We will be maybe... can't tell. It might just host him. Sometimes raids don't work. Not sure why. Well, there we go.